Okay. Let's see if this is working. ¿Dónde? Hello. So, can you hear me? Indeed. How well can you hear me? Cool. How's the audio quality? Is it good? It's pretty really. That's good. There might be some background noise because, kids and dogs. Okay, so just tell me if there's any what's it called? Anything that pops up that's bad in the stream. Uh if you do want to stay, that is. So yeah, I'm just gonna start now. Wanna watch me play some Sudoku? Alright, let's get into the rules. Field lines by MathPesto. Gray cells in the grid form a valid Sudoku. These cells contain the digits 1 through 9, and digits may not repeat in the rows, columns, and 3x3 boxes of the gray cells. White cells in the grid form a valid philomeno. Divide these cells into polyominoes so that no two polyominoes of the same size share an edge. Each white cell contains a number equal to the size of its polyomino. White cells may contain numbers greater than 9. The number in a cell with an arrow is the sum of all philomeno cells in that direction. Sudoku cells don't count towards the sum. If a cell contains multiple arrows, each direction sums separately. For example, row 3, column 3, row 3, column 3 is equal to row 3, column 1 plus row 3, column 2, and row 3, column is also equal to row 2, column 4, and row 1, column 5. Okay, so basically, this is a regular 9x9 grid, as much as regular can be with this. Just imagine that this is all squished together. It's a Sudoku grid. Everything out here is a philomeno grid. And philomenoes would be, for example, if you had a 1 in the grid, that's an area of size 1. 2 is an area of size 2. And both of them would be labeled 2. 3, 3. And then if you had an area of size 8, that's an area of size 8. These are just examples. This would not be possible because 8 plus 8 is 16, and 16 is not a valid Sudoku digit. But say, for example, you had a 1 philomeno here and a 2 philomeno here. Then this would be 3, and this would also be 1, 2. That would be a valid example. Okay, so let's get started. This is a 5-star puzzle, so it'll probably take about an hour. Alright, first thing is always with these arrows, check what they can be. This one is the same as this over here. This is just saying that this philomeno cell is the same as this philomeno cell. Because whatever this is, say it's n, then this thing is just counting that one, which is also n. Therefore, it's part of the same philomeno. So it's 2 or above. Okay. These ones can all be as small as 2, because they could just be 2 1s, for example. So, not the biggest restriction. This one is some of these two, which has to be two different ones or two of the same one. So it's at least 3. This one has to be as small as 4. And it's also counting these two. Because the smallest things you can have here is 1, 1, 1, 1. So this is 4, 5, 6, 7, or 8, or 9. Which means that these also have to add up to 4, 5, 6, 7, 8, or 9. This one's also the same as that one. And then this is at least 3. This is at least 3. At least 3. This is also at least 3. This can be as small as 2. What's this one? 1, 2, 1, 2, 1, 2. Okay, this one has to be a 9. So how I got that is this is seeing straight across over here. And with these two, the smallest these can be is 1 and 2. You can also have 2 and 2, but the smallest they can be is 1 and 2. So that means that each time you have 2 pairs of adjacent Philomeno cells, the smallest they can add up to is 3. 3, 3, and 3 is 9. So this one has to be 9, and these ones have to be 1, 2, which means this is also 1 and 2. These are also going to add up to 9. 1, 2, 3, 4, 5, 6, which means that they can be at most 4. Because if you had 4, 5, 6, 7, 8, 9. I wonder if there are any others like that. These all seem to be looking at, oh, this is also NNN, but they all seem to be looking at small values. The ones outside the grid are not that constrained at all because they could be anything even above 9. So you can have like 5, 5, 5, 5, 5 here, and this could be 25. So we should look at these ones first, the ones inside the Sudoku grid. This one is at least 6. 1, 2, 1, 2. 6, 7, 8, or 9. This one's also at least a 6. Also, this one's a 3. We know this is 3 because this counts 3. And it can't be 2, 2 here because we know that these has to be absolute minimal. 1, 2, 1, 2, 1, 2. If this was 2, 2, then you need to fit 3 more 1s, but 1s cannot touch each other. Oh, also, Philomenos of the same size cannot touch each other. So if you have a 1, then no other 1 can touch it. So then, in order for you to fit 3 more 1s, if those were both 2s, then you'd have to have one of them touching the other one over here. So this one's definitely a 3. If this is a 2, then you have 2 Philomenos of size 2 over here, and then 1 over here. If these are 1s, then it's less restrictive. This 2 just goes down here. One of these is a 2 Philomeno, though. Join to either that one or that one. Oh, this one's looking at this one over here. And this one, therefore, has to be below 9. So this is restricted. The lowest this can be is 1, 1, 1, 2, 2, 3, so that's 4, 5, 6, 7. The lowest this can be is 7, which means this is 8 or 9. So all these has to be 1 or 2. If any of them were higher, such as a 3, then you had the lowest is, no, you could have a 3. 3, 1, 1, 1, and a 2 over here. 3, 4, 5, 6, 7, 8. Yeah. However, I don't think the ends can be 3s. Because if the ends were 3s, then you'd have to have only 2 1s over here, and then 2 2s. So 3, 4, 5, 6, 7, 8, 9. This one cannot be higher than 9. So the ends are not 3s. The ends are 1 or 2. If it's an 8, that's 1. 7 can be 1 or 2. This one's also at least a 6. This one's at least a 4 because it can't be a 3. But I feel like where it's going to be break is somewhere around here. This is where we should be looking. Can it be? Can these be 3? Any one of them. 1, 1, 1, 2 would be forced. This one's also impossible to be 3, for the same reason that the end ones were. Because these would have to be minimally 1, 2, and 1, 2, and that's 9. Are there any other arrows looking at arrows? This one. No. Arrow, arrow. Specifically inside arrows. Looking at outside arrows. Because those are the most restricting. This one's leads to 6 as well. 6, 7, or 8. Oh, this one's looking at that one. It doesn't really say much though, because this could still just... No, it cannot be 1s. This can't be as small as 2. Because if this were a 1 and a 1, that would also be a 1, since that one's looking at that one. And then what's this going to be? It can't be 1 because it's touching 3 1s. And it can't be anything more than it because it's penned in. So this is at least a 3. Not really saying much, but this one's 4, 5, 6, 7, or 9. Oh, yes, okay. So all of these arrows outside the grid cannot go into where they're facing. Because say, for example, that this was a 5. Then if it were to go anywhere over here, say it was over here, then all of these other ones would have to be 0. But there are no 0 phyllomenos in a phylomeno puzzle. Therefore, we can draw this line for all of these. And this is true for any x. If x goes over here, then all of these would have to be 0. And there's no such thing as a phylomeno size 0. The only reason why it works for this one is because that's the only one it's looking at. Oops. That means that these ones are going to have a bit of a hard time getting out. They have to be at least 6. 1, 2, 1, 2. Or 1, 2, 2, 1. But they have to be at least 6. So I'll just do 6x. They could be the same exact number. If they're not, then what would happen? They would both have to get out somehow. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Yeah, they could get out. They'd have to do something like that, though. If they're the same number, though, they have a lot more freedom. 1, 2, 3, 4, 5, 6, 7, 8. They have to be at least 8 if they were the same number. Probably. I think that's how it works. 2, 3, 4, 5, 6, 7, 8. Yeah. So I'm not sure about that one for now. If I can deduce that these are different numbers, then that'd be pretty forcing. Same for this, except it's a lot less, because these can be as small as 3. 1, 2, 1, 2, 1, 6, 7. This has to be as small as 7, but it can go anywhere. So this is a ridiculous pencil mark. So is this. Where does this go? Could go over here, could go over here. Could go over here. It's a lot of escape squares. 3 to be exact. I'm going to write the smallest that these can be with x next to them. 3x, 1, 2, 1, 1, 1, 2, 2 is 7 again. 7x. This is also 7x. 1, 2, no, this one is 1, 2, 1, 2 is 6, 6x. So 6, 7, 8, 9, 9x. Okay, so this one over here is at least 9. We know that it cannot go over here. It cannot take that cell. It cannot take any of these cells because they're all smaller, so it has to escape somewhere this way. And are there any arrows? Yes, this arrow makes it so it cannot go this way. Any other arrows? It cannot be over here because of that one. This one's already looking over here. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, it has a lot of space over here to work with. But it does have all this space. If I can somehow get this down a little bit. Okay. 1, 2, 1, 1, 1, 1. This was 4x. 1, 2, 3, 4, 4x. 3x. Which means that this is a 2, it has to go down here. Not really saying much. 1, 2, 3. This is also 3x. 2x. Could be a 6. Okay. Where do I look next? Again, this feels like the weakest points. This were an 8, so that'd be a 7 and a 1. These would have to be minimal. 1, 1, 1, 2, 2. That's at least a 3 in that, the 5 in that scenario. Is this... If this is 1, 1, 1, 2, 2. That's it. There we go. Okay. This one cannot be a 7. If it were, this would have to be 1, 1, 1, 2, 2. And if this were 1, 1, 1, 2, 2, this 2 would be forced to go here. What's this? Oh no, that's not it. This could be 7 or 8. Darn. Well, 7 in this scenario. This would work 3 through 3. 2, 2 works as well. This would be 5, 3. Yeah, that just works perfectly, in fact. Ah, I thought I was there. Because what I was thinking before is this one has to be at least a 3. In order for it to escape, where can it go? Can't go there. But then I thought, yeah, it would have to go here. It would have to be the 7. Ah, that works so well too. What happens if this is a 1? 2, 2, 2, 1. 6, 7, 8. Yeah, that works. Or does it? No, it doesn't. Okay. If this were a 1, these both would be a 2. They would both have to go down to require the Philomena rules. This one has to be at least a 3. It can't be 1 or a 2. But it can't get out anywhere. It's penned in. So this one cannot be a 1. I believe this one does not have symmetry over here because, well, it can go this way. 1, 2, 2. No, it still does have symmetry. If this were a 1, this one would have to go over here. This would have to be at least a 3, but it cannot get out. It's penned in. So this is also not a 1. What happens if there are only 2 1s? 1, 2, 2, 2 is 6, 7, 8. Yeah, that works. What happens if this is a 2 and it goes here? What can this be? So I'm thinking it has to be a 7 or an 8. Not sure about that though. The only way these can be 3 is if these are all 1s. 3, 1, 1, 1, 6, 7, 8. So if any of these are not a 1, so if one of them is a 2, these both have to be 2. Which means this one cannot be a 2. Because if this were a 2, then it could take at most one of these, but the other one has to be a 3. And then the smallest this can be is 7, 8, 9. Which means we have our second digit in the grid. It's a Flamino digit. "23 minutes and we have our second digit in the grid." That's hilarious. This one has to be at least a 2. Can it be a 2 though? If this, for example, went here, 2, 2, that would be a 3. That'd be a 1. What can this be? Can't be a 1, can't be a 2. And it's penned in. If it went this way though, that's a 3, that's a 1. This can be at least a 3, but then you can just go over here, 7, 8. But that doesn't work. Okay, this is a little bit tough of a deduction. Because, again, we showed over here that it cannot work because this is penned in. 2, 2, 1, this one can't be anything. However, if it goes this way, then still over here that's a problem. Because of what this has to make up. 3, 1, 1, 2, 1. This one, what can it be? It can't be a 2, because then it would touch this one over here. So it has to be a 1. It can't be anything else because it can't escape. This one is therefore broken, because it can't be a 1. So this one is at least a 3. Amazing deduction. Does that mean that this one is broken to be a 2? If this is a 2, then this could either be a 3 this way, or it can be a 3 over here. If this is a 2, this one has to be a 3, that's for certain. And it can either take its last one here or here. It would have to take its last one there, in fact. Because if it went here, then this would have to be a 1, this would be broken. And yet again, that works. This has to be 7, 8, go over here. In the other case, what if this is a 2? In fact, if this is 2 or 3, I think this one has to be 3. No, because this could be over here, 2, 2. 2, 2, 2, 1 works, yeah. Hmm. Is this 5 in all cases? Hmm. These are both 2. I don't even want to look at that. Well, this one can't be a 1. Because if this were a 1, this would be a 2. We'd have to join up with this one over here to minimize this. And then this one would have to be 1, 2. Which it can't be because there can't be a 2 over here, touching this 2 Flamino. So this one has to be 2 or 3. Or X. It could just be this one and go all the way over here. Two, 3, 2. Yeah, that works. But yeah, again, this shows that this is a 5. What's the highest this can be, actually? This is a 7, yeah? Because if this was 7, this would be a 2, this would be a 9. Which is the highest that can be. Which is impossible. This one cannot be a 7. If it were, this would be penned in. 1, 2, 3, 4, 5, 6, 7. 2, 1. Where's the 2 go? It can't. So this highest this could be a 6. This for a 6. 1, 2, 3, 4, 5, 6. I think we probably have the same problem. Because this would then have to be 2, 2, right? Which means that a 2 and a 1. 2 goes here, that's a 6. That does work, though. No, it doesn't. For a more complicated reason. Because of math. If this were a 6, it has to come out through here. This one, these two have to join each other. 2 and 2. Makes that a 2 and that a 1. Right? So what does this add up to? 6, 7, 8. This would be an 8. But then what does this add up to? 8 as well. No, no, it does work. It does work. Because that's the 8. That'd make that a 9. And that'd make that an 8. So many things that like feel like they won't work and almost don't work, but then they might. It'd be very forcing if it was the case. I don't think this can be a 5 though. Can it? 5, 2, 2, 2, 1, 2 and 5. Yeah, that works. Is there ever a case where this one does not go here? Because if this goes here, then these two have to be the same. Always. But if it doesn't, it could do that. 2, 2. If this were 3, that'd be 1, 4. 4 would be 1, 5. Yeah. So there is a case. Though, if this is 2, 2, which makes this 2 and 1, this would have to go here. The highest this can be is 3. In fact, that's the lowest it can be. lowest and highest, which means it would have to be 3. Five can't be 2, 3, would have to be 1, 4, but we showed that before. Can this ever be a 2? If that were a 2, that'd be a 7. 1, 2, 2, 1. Seven as well. 2 would have to go here. Yeah, again, this works. Is this ever an 8? That'd make that a 7, that a 1. 1, 2, 2, 1 again. Truly. I do feel like this part of the grid is where we have to do it. Because everything else is so less restricting. So much less restricting. Actually, what's the lowest this can be? 2 and 3, right? Because if this were... The reason why there's a 2 over here is because it goes up with the 2 up there. 1, 1, 2 goes down there. 2, 2, they can't touch each other because that would make it at least 3 cells. 2 goes down there. Which means that wherever the 2 is, it's seeing both a 1 and a 2. So this is at least 5. 5 plus 3 is 8. This is at least an 8. Which means one of these is a 1. This is 2, 3, or 4. Whatever the 1 is. 1 cannot go here. Because if 1 went here and 1 went here, if 1 went here, it would force this 1 to go here. This would have to be a 2. It would have to come up here, which it cannot do. Because this is at least a 3. So these 2 are 1s. This is a 2, makes that a 2 as well. There we go. I feel like it has to be up here. I thought I go over here to find something immediately. That's hilarious. This is at least 3rx is the same as this one. This one also goes up here. Oh, because this is at least a 3. 5, 8, 9. Yeah, this one has to be a 9. There we go. This one, that means that this one has to be a 3. This is minimal, 2, 3, 5, 6, 9. Which means this one cannot go here because this is at least a 7. The last one has to be around here somewhere. One of these is a 3, because the 3 has to get out somehow. We have some progress. This one can't be a 4 anymore. Can it? No, it can. Because, no, it can't be. Oh! Oh, this is really good, actually. This one is the sum of these 3. Which means this is double this. 1, 2 is 3, 4. This is at least an 8, which means it has to be an 8. There we go. 1, 2, 1, 4. Which means this is a 4. Which means these are all minimal 1s. Just to show what I did there. I can't believe I wasted so much time up here, oh my gosh. Well, it won't be waste, because we'll see later on it'll be easier to do. But these 3 are at least 4. 3 over here and 1 over here. Which means this one, which is kind of this 3, is at least a 4 as well. And because we have 4 plus 4 is 8, that's the most this one can be. Therefore, it has to be that. Which means this is a 1, that's a 2. This one is at least a 5. It can't be 2, because then 2 would have to come up here and it would break that one. So this is 2, 3 at least, which means this is at least a 5. Which means that this one cannot go there. This is most likely going to be the same as this one. This one could do that. 1, 2, 3, 4, 5, 6, 7. This would have to be the same as that. Or it goes here. Ooh! These have to be 4. How is that possible? What? Oh no, did I break it? How is this? Can this be a 1? I proved before this couldn't be a 1. Same as this one. This one has to be. 2, 3, 4 would have to be the case. So, why does this one have to be a 1? How is it possible for this to be 1? Why did I prove before that it couldn't? Because this would be 2, right? That'd be 2, that'd be 1. This would have to go up here. This one has to be at least a 3. That's why. Oh no. And I proved. Keep that there. This one obviously cannot go there. This one has to be here. This one. What did I do wrong? Why did I break it? I think I have to redo this stuff. The logic here. I did something wrong with logic here. I had to. Because everything over here is good logic. Oh, this one has to be a 3 as well. These are all 1s. Don't know why I'm doing this when I possibly broke the puzzle. Okay, let's redo the logic over here. I did something wrong. I had to. I had to have done something wrong. Most likely this being a 1. How can this be a 1? This is minimal 7. That's true. Let's just pretend this doesn't exist. Let's do it from here first. This one has to have 4 remaining. This is definitely a 1. They could both be 1s. This would be a 2. So this is 1 or 2. That means that this one is not a 1. It could be a 2. And it could join into one of these. But now that this is not a 1, that means there are max 2 1s on this line. Which means that there are, at minimum, 3 2s on this line. 6, 7, 8, which means this one has to be an 8. This one has to be a 1. This one has to be a 9. This one can't be over here anymore. Has to go here. Oh, also, we know that these don't contain 3. This is 1 and 2. Just a bunch of 1 and 2s. And these are flip-flopping 1 2s. Not necessarily. These 2 could be a 2. I mean, that's where I did it wrong. Yeah, that's probably where I did it wrong. These could be a 2. These could both be 1s. This could just come straight out here. No, it cannot. Again, this one has to be 1 or 2. One of these is a 2, which means it completes this one. Or they're both 1s, so never mind. Because this one could go here. But yeah, this could be an 8. Which means this one is either 3 or 4. 3 would make that a 1, that a 2. 4 would make one of these a 1 and a 3, or 2 and 2. No, it can't be 2 and 2 because of that one. So one of these is definitely a 1, 1, 2, or 3. I'm not sure what the logic was before that broke this. However, I'm just going to forget that I ever made the logic. Therefore, it doesn't exist. Oh, this one's a little bit. This has to be a 2 or a 3. In fact, it has to be a 3. You can't contain a 1 over here anywhere. So this has to be 3. Which means this one is a 4, this one is a 6. 4 has to go at least there, and it's finished. Six, 1, 2, 3, 4. Has to contain one more over here, over here. It cannot be here, because then this would be a 12, so it has to be here. Because this is a 6, this is at least a 7 over here. It has to be at most 8s. So this is 1 or 2. Can this go here? If these are both 1s, this would be a 2. This would have to be at least a 3. 1, 2, 3. And 2 and 3 is equal to 5. So it cannot. Oh, also, this obviously can't be 2 1s. Because this is at least a 3. That's a 3, 1 and 2. This is not a 2. Which means this is a 1. Which means that this one has to jump to this next. Now. Well, actually, we knew that before. So that's at least a 6. Has to go here. Can't go anywhere over here. So 1, 2, 3, 4, 5, 6 has to join up with the 8s. So this is an 8s. Oopsie daisy. Can't go anywhere over here. 1, 2, 3, 4, 5, 6, 7, 8 has to finish over here. This means 7 more over here. How is that possible? What is this? 1, 2, or 3? That's just lowest it can be. 3 cannot be the case because that'd be a 9. 2 would make that a 4. 4, 5 would mean 3 more, which is possible. In fact, it's likely. If this were 2, though, if this were 1, though, what would this be? 2 means 6 more, which means this would also be a 3. But then it would break over here. So this one has to be a 2. Oopsie daisy. This is a 3. Making a lot of progress now. That's good. This is 1, 2. That's a 1, because then this would break. That's a 2, 2. This one's a 2. 1, 2. This one cannot be a 2, because then I'd have to take over here. So that's a 1, that's a 2. Yeah, most likely what happened over here with the logic was I did not account for this. What can this be? At least and at most a 3. This is at least 3, 3x. This one now is much more than 9. That's at least 9. 10, 11. This is 11x. Where can it go, therefore? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, it's getting a lot more cramped in here. If this were a 3, then that would be the exact thing it has to be. It cannot be anything more than a 3 unless it is this. And it joins up to this. So this is either 3 or this one. What's this? 10, 14. This is exactly 14. This is a 2. This one is 8. Which means it can either be 2, 6, 3, 5, or 4, 4. It cannot be, it has to be the same. 1, 2, 3, 4, 5, 6, 7. Therefore, if these were different, they would have to take 7 spaces, but they add up to 8s, which is impossible. So these are both 4. And they connect. One is a 4, the rest are 1 and 2. Which which means this is an 8. This one therefore cannot be a 4, so this is a 4. Otherwise this would also be an 8. This one is, this is a 2. Either 5 or 6. This one is 3 or 4. This one is a 6. Therefore this is a 5. 1, 2. That section is complete. Oops. This one's a 4. This one's at least a 6, which means it's a 7 or a 9. Which means this is a 3 or a 5. Comes over here as well, 3 or 5. And because this is the same number over here, that means that this one has to be a 4. Because x plus 4 is equal to x plus 4. This has to go at least here, because this is at least a 3. This one therefore is also a 4. This is 4 or a 6. Cannot be 6, it has to be 4. Because it's Sudoku. This is a 7. This one is 1, 3 or 2, 2. And this can be is 4, 5, 6. Which means this is 6, 8, or 9. What is this? We now know it's 5 plus 9 is 14. This is 14. Which means it has to take all this, right? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yep. This is all 14. Let's give this a blue. Actually, no. Let's give this a brown. This one has to complete here, 4. This is also a 14. Baby's crying. This one has now gotten bigger than 6. This least it can be is 2, 1, 1, 4, which is 8. This one can also be 2, 1, 1, 4. No, it cannot be. But it could be 1, 2, 2, 1. No, it can't be, but probably where we're gonna look next. If this is a 3, can't go here. Has to be here. 3, 3, 3, 1. Then 2, 4. Or 2, 4. If this is a 3, and that's a 1, it could even do that. 3, 1, 2, 1. No. No, it can't. That were a 3 and that were a 1. This has to be at least a 2. Have to come here. It can't be. Oh, it could be a 4 though. Yeah, that's what it would be. This were 2. Ah, yes. If this were a 2, 2, what can this be? It has to be 2 cells adding up to 2. That can't be a 2. That would be 1, 1. It cannot be the case. So this is 1 or 3, which means 3 either goes here, with a 1 there. Well, that's a 3, that's a 1. This one could still do that. Three, 1, 4, 2 is one scenario. 3, 1 either goes here, that's a 4. That's a 2. Or it goes here. That's a 4, that's a 2. Yes. In both of these, are any of these the same? This is the case, 3 and 1 over here. We have 3 through 3, 1, 2 and 4 over here. 6, 10, 12, and 14. In fact, where does this 14 go? 1, 2, 3, in fact, where does this thing? What is this maximally? And what is that? We didn't do more arrows, I believe. Shh. Whatever this is, it goes here. Four, 5, 6. Where's 4, 5? So this is 2, 3, 4, 5. Ah, this obviously cannot be a 4, because one of these is a 4. And because one of these is a 4, it either goes with 2, it can't go with another 4 to make 8s, and it cannot be with a 5, because then the 5 would be penned in somewhere. So this has to be 4, 2, which means the 2 goes over here to complete itself, and these ones are 3. 2, 4 makes that a 6, which means this one is a 2. This one's what's going to differentiate this between the 1 and the 3, because either this is a 3 or a 5. But we don't have any Sudoku to tell us which is that yet. How is Sudoku doing, in fact? 9 goes here. This is 1 and 7. No, 1 and 2. 1, 2, 3, 4, 5, 6, 7, 8, 9. Can we do anything else with Sudoku? Oh, this 8 makes that a 7. Makes that a 1. This one's no longer a 7. How is this going to differentiate between the 2 and the 4? How is that possible? Is there something else looking at this? Yes, this, obviously. Hey, dogs. The dogs are so cute. This one's not an 8. It's 6 or 7. Which means that this can be maximally 3. 3, 1, 1, 2. 4 and 3. 7. They're both little gremlins. This one's much more than 7 now. 10 plus 4 is 14 at least. It's probably gonna be a lot of 14s in the grid, I'm guessing. 14 seems to be a common number. What if that had anything to do with the tile field lines? I don't know. I don't know sports. Hmm. What can these be? 6, 10, 12, or 14? If that's the 3. If this is the 3, then 6, 10, or 12. If this is a 1, that's 4, 6, 8, or 10. 8, 10, or 12. Yeah, this is a 2. 4, 7, 8, or 10. If this is a 4, 6, 9, 10, or 12. Yeah, so it's either 8, 10, or 12 for that one. This is a 4, 9, 10, or 12. This is a 4, then 11, 12, or 14. Can these be different? Or do they have to be the same now? What do these add up to? 3 threes, 1 1 is 9, 10. 2 fours is 18, 20, 24. These add up to 24. So if they're separates, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Yes, it adds up perfectly, in fact, which makes me think that that's the case. Which means, is there ever a case where these are not? Can these ever be the same, in fact? 3, 1, 4, 2. Let's do this example. 6, 10, 14. This is a 10. Or is it 8? This is 8, yeah. How about over here? 12 and 10. No. So then what if this is a 3 and that's a 1? 6, 10, 12. 6, 9, 10. Wait, what is that up to again? I think I could have just did it by math. 8, 11, 12, 6, 8, 10. Yeah, because they have to 22, don't they? 9, 10, 14, 18. No, 22, which means half that would be 11. These can't be 11 as before. So these ones have to be different. And it takes all of these. These all are taken by these two. Whew, there we go. Which means one of them is a 14, because it has to take this. It's the only one that can be a 14. 14, 22 is 8, so this one's an 8. 1, 3, 4, 2. Right? 6, 8, 14, yep. Sometimes all you have to ask yourself is there math I'm not doing? Sports field has multiple versus so much hate. I'm gonna shake my head. It's brown. Make this a yellow. Oh, wrong yellow. 1, 2, 3, 4, 5, 6. 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Amazing. Which means this one is a 5. I thought this would have been taken care of by Sudoku, but it's actually just taken care of by this. These are all 8s. These ones cannot be 2 anymore. Because if it was, this one would be broken. So these both have to be 1, that has to be 2, that has to be 3. Excuse me. What next? Where to next? Because we just did the entire top half of the grid. This 14 means that this one is at most 6. This one's at most 12. No, it cannot be 12. These cannot be a 1. This for 4, this would be 10, cannot be the case. 6 would make that an 8, which cannot be the case. 4 would make this a 6, which cannot be the case. So this is 5 or 6. 5 making that a 4, 6 making that a 2. What's the most this can be? This is a 3. At least a 3. 4. This is at most a 5. 2, 3, 4, 5. 2, 3, 4, 5. Can it be a 5? 1, 2, 3, 4, 5. Yeah, that works. Works pretty well, in fact. What can this be? This is 6. 6, 7, 8, or 9. Which means this is 1, 2, 3, or 4. Cannot be a 3, because that'd be pendant by itself. Could be a 2, could be a 1, could be a 4. Which means this one has to come up here to get the 5 over 6. 1, 2, 3, 4, 5. Yeah, it has to connect over here. And it can't just be over here. That's why. This one's 2 or 4, so this one has to come up here. If this is a 3, this can be a 4 over here. 1, 2, 3, 4, 5, with a 2 there. That works. Otherwise, well, this one has to be a 4, in fact. 1, 2, 3, 4, 1, 2, 3, 4. If this is a 6, where's it go? In fact, this cannot be a 6. 1, 2, 3, 4, 5, 6. And this is penned in. So this has to be a 5. Which means that a 4. It could go here, or it could go 1, 2, 3, 4, 5, and cannot go there. In fact, 1, 2, 3, 4, which means this one has to come at least 1 down here, which means it takes that one. And it's done. This one has to be a 2. This has to be a 7. One of these is a 2 by Sudoku. One is a 2 and a 3, in fact, by Sudoku. 1, 2, 3, 4, 5, 6, 7, 8. This is an 8 or 1. This one is an 8. This one has to be a 9 because it's a 5. 6, 1, 2 makes that a 9. This one has to be the 1. This is a 2. This is at least a 3. Which means what's this? 6, 16, 17. It's at least a 17. Ah, we've ruined the dream of it being 14. This could be a 4 and that a 1, or 4 and that a 3. This is a 3 and a 4. 3 or a 4. What's this? At most a 4. 3 or 4. Na 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 na. This one has to be a 4. This is 1 or 4. This one has to be a 4. Can I do this without a 3, or this without a 1? This 17 has to get out over here. Whatever it is. Make it purple. Which means this one, which cannot be a 17, is at least and at most a 3. Which means this one is 17. This one's penned in. Maybe. This could be a 17. In fact, what is this? 7, 10, 12. At least a 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yes, this one has to be at least 17 now. Because either the 17 escapes through here, which makes it a 17, or it escapes through here, which makes this much more than 17. In fact, 17, 20, 25, 29 would be. This would have to be 29. Can that fit? No, it cannot. Definitely cannot. This is all penned in. This is for 29. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. It just would not fit. So this one has to be the 17. Which means this 7, 10, 12 makes that a 5. 17. One, two, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Yeah, this has a lot of space to fit. This could be... cannot be 1, 6. Because if this were a 6 and a 1, what would this be? Cannot be 6, and it cannot escape. Same for this way. Again, cannot be 6, cannot be more than 1. This is 2, 5, or 3, 4. And whatever this is this one. 2, 3, 4, or 5. 1, 2, 3, 4, 5. This one cannot reach over here. 1, 2, 3, 4, 5. This one can. 5, 2, 1, 1 would work. But if it doesn't, 1, 2, 3, 4, 5, 6, yeah. If this doesn't reach here, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. Can this fit? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Yes, it fits perfectly, in fact. Ah. So either, if this is a 2, 5, this can just go to this one. This one obviously cannot be the 5, or it can be. 1, 2, 3, 4, 5, 1, 2. Then this one would just have to take the rest of them. So either this is a 5, and there's a lot more freedom, or this is a 5, or this is 3, 4, and all of this is maximized. Don't think we can do that just yet. There's a 1 in each of these sets of digits. That's interesting. One of these has to be a 2. This is probably going to be a 2-hour solve. It's probably going to be done in 40 minutes. How can this be? At least a 5, right? Because one of these has to be a 2. It's the same logic that we did over here. So this is 5, 6, 7, or 8. Ah, children. Sorry if you can hear them in the backgrounds. I got all of the top and lefts. All I have to do is go down to the bottom and then complete the Sudoku. The Sudoku's probably gonna be trivial once we're done with it. Once we're done with the Philomeno. Eight's over here. Nine's over here by Sudoku. Nine's over here by Sudoku. In fact, nine's over here by Sudoku. Because those nines looking at it. 1, 2, 3, and 7 is placed in this box. 2, 3 goes here. 1, 7 goes here. We said 1 and 8. Oops. 1, 8. 5 and 6 to go over here. 4, 7, 8 to go over here. How is this not the same as that? If this, that's how. Okay. If this were a 2, 2, and this were 3, for example, This 2 is counting both the first digit for this and that one, which means that these two have to be different, which is impossible since it's greater than 1. So this one has to be the 2, this one has to be the 1. And just to show you what I mean there, to make it more clear, if this were a 2, that were a 1, this one has to be at least a 3. Whatever it is says x. This one is counting x plus 2. This one's also counting x plus 2. And because those are the same number, these would be the same number, but that's impossible by a Sudoku. That's a little one. This is 3x. In fact, it's 3, 2, 6. 3, 4, 5, 6. This is the max it can be. If it went here, then this is either 3 or 4, making that a 6 or an 8. In fact, it can't be a 4 because that 8. So this would have to be 3 if it went here. Otherwise, it goes here. Intriguing. Where does 9 go in this box? Can't go there because this 9, can't go there because this 9, because it has to be somewhere over here, which means 9 over here goes there. 1, 2, 3, 4, 5, 6. These two are 5 and 6. Seven goes there. Not interesting. 8 goes there. 7 goes there, which means this is a 7, that's a 1. This is at least a 4. 4, 5, 6, 7. This one cannot be a 6. So that's not an 8. But if this were a 6, 6 would have to, it cannot go there because that'd be a 12. It would have to go here. That makes this a 7. That an 8. Then what's this? It has 6 here, it's at least a 6. It can't be 7, 8, or 9. It's impossible. That's not a 6, that's not an 8. And the same thing with the 5. 5 here. 7. 6. 6, 7. Could be an 8. So no, I can't do the same thing. Either this goes here, or it goes here. If it goes here, it's a 3. Where does 9 go in this box? Over here. Could be a 4. If it were 4, that'd be 3 and 1. Yeah. That works. Down. Run it down. They say the memory of me is fading. Does anything else fit here? 4, 5, 9s, 8s. Hmm. 3. Interesting. We're so close. Just need a couple more deductions. If this is not a 3, then it goes here. 5 makes that a 1. 4, it could be a 1 or a 3. Could it be a 3? If this were a 4, this were a 3. Has to go there. Which means that a 7 and that a 7, which is impossible. So no. This one could only be a 1, if this went here. Because if there were anything more, and it weren't this one, if this were a 4 or 5, then it would come over here, and you have both 4 plus x on both these diagonals, as pointed out by this. Oh! This can't be a 5, obviously, because that's a 6 or a 7. If this were a 5, that'd be a 7. This one would be minimally a 6, that's the max it can be over here. 6, 7 breaks that. So that's not a 5. Oops. This is 3 or 4. Make that not a 7, 5 or 6. If this were a 4, that'd be a 1. 3 could still go here. That'd make that a 1. Yeah. So it's either 1 or 3. That is for sure and certain. 3, 3 makes that a 6. 3, 1 makes that a 4. And 4, 1 makes that a 5. So it's not a 7. 4, 5, or 6. A little bit interesting, I'd say. Can any one of these not be a 6? If that were a 6, that'd be 5 and 4. Yeah? That makes this a 3 and that a 1. Yeah, that works. That makes me want it to be a 6 now. Na, 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 na. I've heard it all before. If this goes here, this one counts these two, plus that one. 3, 1, miss that. At most a 5. Sorry, at least a 5. 5, 6, 7, or 8s. However, it could also just be 3 here, 1 and 1, which is also a 5. 3, 4, 5, yeah. Aren't that many degrees of freedom? say. Seven, seven, seven. Either way, this is so very forcing. If this is 6, 5, 4. If either of these is 6, it's a 7. It has to be a 5, actually. No, it can't. If this were a 5, that would be a 6, making that a 4. And then you have a 4 on this path. These two have to add up to 1. Two cells can add up to 1. This is 6 or 8. If this were a 6, that'd be a 5, that'd be a 3. These have to be... 3, 1, 2, or 3, 1, 2. Possible. If this were a 6, 4, these have to add up to 4. 1 and 3. Which works. Both those work. I am loving this puzzle, by the way. Each one of MathPesto's puzzles just keeps getting better and better. This is at least a 2. No, it can't be a 2. If this is 1, 1, what's this? 3? No. So it's at least 3, but it can't be, so it's at least a 4. 4, 5, 6, 7, 8. Unfortunately, does not form a quadruple. 4, 5, 6, 7, 8. Yeah. If I can get rid of 8 here, this is a 1. 3. No, I can't get rid of 8s. Bum, 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 ba-dum, bum, bum. There's some sort of restriction to this space, I think. Four, 3, 1. Not interesting. Is it? 6, 5. Is that 7 or 8, which is 3 or 4? Almost. It's almost interesting. This is why I always recommend variant Sudokus, because you just get sucked into this world. This is just one of MathPesto's puzzles. I think the longest I've ever taken on one of them was like 4 hours, I think. This one's gonna be 2 hours, which is close, but what am I missing? What clue am I overlooking? Could this really be a 9? There's so many options there, it's not plausible to even think about. This really is, though, the last corner I have to think about before I have to start doing the Sudokus. The quiet in the background. Better do. Whoa. Hmm. This for 1, 2. This could also be 1, 2. This could be as little as 3. Because this can go that way. I already have that. All the arrows up here are done, yeah? This is done. That arrow's done, that arrow's done, that arrow's done. All those arrows are done. So is that, and that. That arrow's done. Yes. Yes and yes. Ooh, this one. 14. Ooh, that's what I'm missing. This one right here. This cannot be anything more than 14. Which means this one has to go here. Has to go there. One, two, three, four, five. This one has to go down here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I'm always missing something, aren't I? 4, 9, 11, 13, 15, 16, 17. And that's done over there. Wow. It was camouflaged. This one has to be a 3, this one has to be a 4. And I'm finishing up with this side of the grid. $17. 5 goes here, has to go there. This has to be a 2, has to be a 1. can't believe I missed that. Ah, this is at least a 3. In fact, it's at most a 4. And it cannot escape through here, because this is at most a 3, but this cannot go over here. So it's either 3 or 4, which means this one could be a 1, 2, or 4. Just to make sure I'm not missing anything else like that. Well, this one still is counting over here. If this is a 4, that'd be 8. 2, 3. In fact, what can this be? If this were a 3, and that were a 1, that'd be 4. This would have to be 10, which is not possible. This is not a 1. If this were a 2, 3, 2 makes that a 5, which makes that a 9. But this cannot be a 9, because that. That's not a 2 either. This has to be a 4, has to connect to this one. So this is 8, has to have 6 more over here. This is a 6. 4 or 5, this one cannot go here anymore, cannot be a 6, has to go here. 3 or 4 makes that a 1. This can still be a 6. Oh, in fact, no, it cannot, because this is a 6. 2008. This needs 7 more, which means this is a 3 or a 4. And these two have to be different, obviously. This is not a 6. This is a 6, that's a 5, that's a 7 by Sudoku, which means one of these is a 3. Oop, button chat. Let me get rid of that. Oop, that's... There we go. I just really want those cheap viewers, what can I say? No, you don't want them. Don't waste your money on scams. Can this be a 4? No. If this were a 4, then also this can't be an 8. This can't be a 7. But if this were a 4, this would be a 3, that'd be a 1. This is done. This one has to get out somehow, but it can't be a 1. Impossible. This is 5 or 8, therefore. This is a 5. This is 2 or 1. If it's a 1, that's a 4. In fact, what is this? It has to either go here or here. So that would work for 5. 1 or 2. 1, 4, 2, 2. If this were an 8, however, does that work? Also, one of these has to be a 5, right? Yeah. Because if this is a 3, then that's a 5. If this is a 4, then that's a 5. Therefore, one of these is a 5, this one has to be an 8. Which means this is either 4 or 5. 3, 5 makes that a 5. 4, 4 does not work. If this is a 4, that would be a 4. This one cannot be a 4, because then we connect these two. It cannot be a 1, and it can't get out. That's a 3, that's a 5. That's not an 8. This is an 8. This isn't a 7. Close up this. This is a 4 now. Can't be there, because one of these has to be a 2 or a 3. So 4 has to come out here, 5 has to come out here. This is at least a 5, so it's at least a 6, 7, 8, or 9. Can't be 6, can't be 7, can't be 8, has to be a 9. This is a 4. This one has to be a 1 to complete that. This 5 has to finish. Four goes somewhere over here. If 4 goes here, 1, 3 has to finish it off. 4 goes here, same thing, 1, 3. So this one has to be 1, 3, which means this one has to be 1, 2. And 2 goes here. This one's a 3. It's at least a 5, 5 or 7. This is not a 9. That is a 9. 8 is over here. Neither of these are 7. This one's done now. 4 and 5. We set a 7. So that's a 2 and 5. Where does 5 go? Over here. 1, 2, 3, 4, 5. Can be any of these. Oh, it can't be these two. Only one of these can be a 5, which means one of them has to be a 5. 1, 2, 3, 4, 5. Yeah. This is 1, 5. These are all 5. This one cannot be the 1. Wait a minute. Whoa, no. No. I broke it. What did I do wrong? Where did I go wrong? 4, 3, 7. Because if this can't be 5 or 1. Otherwise, this thing has to get out. Can't be 3. Because 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. That's correct. Wait, this can be 1, 2, 1. That's why. Oh my gosh, I'm such a moron. Let me just rewind back to where I put that in, just in case. There we go. This can be 1, 2, 1. That's much as obvious. This one is at least a 2, and it can't be 5. Which means that this, 2, 4, 3, 3. Both those work. Let it all say. This one's 2, 3, or 4. Has to go out here. It cannot be 3, because then this would break. 3, 3, 3. If this extends any further, then it makes this more than 3 cells, and this one cannot be 1 cell. That's not a 3. This is a 2, 4 pair. This is 1, 2, or 4. This is a 2. 4 has to go over here. This is a 4, and 4 has to go over here, take at least one of these cells. So because 4 is in one of these cells, that means this one is greater than 4, has to be at least 5. 5, 6, 7, cannot be 7, has to be 5. This is 1, 4. So one of these 2's either goes here or there. Two has to go, 2 or 3 has to go here. And it cannot be with a 1. So it has to be at least a 5. It can be 5, 6, has to be a 7. And it can't be or not either. It's either 2, 5, or 3, 4. Cannot be 2, 5 because there's only 3 cells here that can contain 5. So this has to contain 3, 4. Which means this is a 3, 1, 3. Makes that a 4. That's a 1, 2. 1, 2 makes 3 cells, which means there has to be 1 over here as well. Can't be there, can't be there, has to be there. That's a 1, it's a 4, 2, and 1. I forgot to do this again. 5. 3 has to go here. 1, 4 goes there, that's a 2, 2 and 1. And there we go, we're done with the Philomeno. Now all we have to do is Sudoku. And we're done. Okay, we'll start from this box, 1, 2, and 3. This one's a 1, make it single. 2 and 3 looks at it. These are 2 and 3. 8, 9, 7, 6. 6 goes in one of these 2. Again, these can't be 7. 8 goes here. 9 goes there. 8 goes there. Face makes that a 5, that is 6. 6 goes here. Goes there in that box. 4, 3, 1. This is not a 4. This is not a 1. Okay, this is 1, 2, or 3. Also 1, 2, or 3. 1, 2, or 3. It's not 1, it's not a 3, it's a 2. That's a 7, that's a 4. This is not a 2, this is 1, 3, or 6. Oh, 6 can't go there. Has to go there. 5 goes to one of these 2 cells. This is 1, 2, or 4. This isn't a 1. This isn't a 4. This one is a 4 over here then. 4 is one of these 2. 6 is here. 7. 5 is one of these 2. 5 is one of these 3. This is 1, 2, 3, or 4. Never mind, I'm one of those 2. This is also 1, 2, 3, or 4, not 4. 1, 2, or 3. We're so close. We have a couple cells left. This is not 1, 2, that's 3 or 4. 7 goes here. Oops. 1 has to go here with 4. That's not a 1. 2, 3 makes that a 1. Which means that's not a 1. Which means that is a 1. Which makes that a 2, that a 2, that a 3. That a 3. That a 2, that a 3. This is 2, 3, 4, 5. This isn't a 3. Just have a couple of deductions to make. 2 and 5. This is a 2, that's a 5, that's a 5. That's a 1. Then we set a 2. That a 2, that a 3, that a 3, that a 1, that a 1, that a 2. That a 3, 4, 5, 4, and 3. And then 4 and 1. And there we go. In basically 2 hours. 1:18:45. All Sudoku's done. All Sudoku's correct. And all philomenoes are philomenoed. Except for the 14s and 17s. But yeah. That was Field Lines by MathPesto. I really enjoyed that puzzle. I just cannot express how fun this puzzle was. It was awesome. So yeah, I'm probably done for not today. I might come back later today, but I do have to go to the gym now. So maybe after I come back from the gym, I'll do some more math puzzles. But for now, it's a 2-hour puzzle. Indeed. I actually reached my peak weight yesterday, which I'll tell you over text, because I don't want to say over stream. But yeah, thanks for coming. Gonna end the stream now. Bye bye.